created using Powtoon.
So now we're going to demonstrate this mousetrap car, and we're going to talk about Newton's laws. Let's demonstrate this. Yeah, that football was marking the 2-meter mark, so we went pretty beyond that. So let's talk about Newton's laws in relation to this car. So let's look at Newton's first law. Newton's first law says that an object at motion will stay at motion unless acted on by an unbalanced force. And this also works for objects that are at rest. So the balanced forces in this car are gravity, and the normal force, because it's not moving up or down. The only unbalanced force is friction. And generally for the car, and I say generally, you want to reduce it, but there are some catches, but we'll get to that later. But the reason why friction, you generally want to cut down on that, is because the friction is the unbalanced force, and a greater unbalanced force will cause the car not to move as much, whereas a lesser unbalanced force would cause the car to move more, because if you had zero unbalanced force, it would just keep going until it hit something. So there are a few ways you can reduce friction. One of these is by the eye hooks, and there are specific ones that are a bit different for the wheels, the axle, and the wheels on the ground, and those are the different ones. But generally, see here, this is very open. There's not a lot of friction going in here between the eye hooks and the axle. So this is what I'm talking about. This has very free movement. This means these can move very easily. So I cut down on the friction in certain key areas, so I didn't have an unbalanced force weighing this car's movement down. Now let's talk about Newton's second law, which states that force equals mass times acceleration. And then by this, we can derive acceleration equals force over mass. Now force is a constant. It's this spring and this string. It's the force applied to that. So you can't really change that. The one thing that you can change is the mass when you're building it. So what I did was I made this very thin. I cut out an extra piece of wheels, and then I got just one big wheel. And then you see that you want a lower number in the denominator because, for example, 10 divided by 1 is 10, but 10 divided by 2 is 5. So you want a lower number because it's going to be lower if it's greater in the denominator. The reason why you want a greater acceleration is because it's going to reach more velocity, which means that it can get farther distances in a shorter amount of time, which is good. Now, Newton's third law explains that every action has an equal and opposite reaction. And there are a few things in this mousetrap that demonstrate this. For one, when you hit this on the mousetrap, it goes with a force, and then the mousetrap hits back with an equal force. It doesn't move. And then you see this in several other things. And the big one here is the wheels and the movement. So every action does not necessarily say forces. It can just be movement. So when this thing is moving, the wheels are pushing against the ground. And a person unfamiliar with physics would say, how is that possible? Because you're moving against the motion. Well, that is in accordance with Newton's laws. But think about this. If you're walking, you push against the ground. You don't push in the direction you want to go, because then you'll just go backwards. So we see that in the same way that you walk, and it demonstrates Newton's third law, pretty self-explanatory. We see that same in the car, because if you move this, you see the cars are going against the ground if I'm moving it forwards. So that's how Newton's third law works in tangent with the car. And then the other Newton's laws I did explain. So hopefully you see how Newton's laws are addressed with this car.